Hello and welcome to the Future of Smart Cities by CM Industrial. During this week-long webinar series, we plan to find out how smart cities will impact the future of industries that we serve as talent solutions provider. I'm today's host, Lau King. I am a business manager here at CM Industrial, and this webinar in particular is all about how to build a smart water network. To discuss this, I'm joined by an expert panel of well-established water leaders. But before we get introduced, just a quick reminder to everybody that is on the webinar that we will be running a live Q&A. So if you do have questions, please feel free to drop them in the chat. And what we'll do sort of towards the end of the webinar is we'll do our best to address them all. So to kick things off then, Gavin, would you please introduce yourself and tell us a little bit more about yourself and what you do with NEOM?
Sure. Good day to everybody. My name is Gavin at Tonder. I am the head of water in NEOM in Saudi Arabia. We're building a new region out, and we're building it out from desalination all the way through to transmission, distribution, wastewater treatment, and recycled water, as well as mineralized water in networks. So we have a greenfield opportunity, and we're going to be implementing smart networks, but not just smart network water, of course, a smart network across the whole region and each of the cities. Previously, the president of Untitled Water, which I guess arguably is one of the biggest smart city, utility smart city providers in the world, and been in NEOM for around 3 years now.
Perfect. I'll direct that to David then. So again, just a quick sort of 60-second introduction to the work that you do, David.
Morning. My name's David Lloyd-Owen. I run a consultancy called Envisager. I specialize in advising multilaterals such as the World Bank, companies, governments, and financiers about water policy with a specific interest in finance and project deliverability. I wrote a book a couple of years ago on smart water for Wiley, and I have been keeping an eye on the development of smart water, in part from my previous background as a technology analyst before getting into the business of water analysis in the city back in the 1980s. And my particular interest these days is trying to integrate smart water with water use efficiency and demand management in practice.
Perfect. And just to move it on to Slavco, last but certainly not least. Slavco, a quick introduction.
Yes, thank you. Good morning, Lyle. Good morning, colleagues. Good afternoon, where you are in the world. My name is Slavco Velickov. I'm working for Bentley Systems as a global industry water director. Basically, we are supplying technology for implementing smart water networks based on potable water irrigation, but also wastewater collection networks as well. I'm working with utilities around the globe, obviously, and also with engineering consultants to drive digital transformation and implement this type of technologies.
Excellent. Thank you all very much for those introductions. So we will obviously get straight into it. And I suppose like a starting point that I think before we get into the details, a good place to start is a definition of what a smart water network is. So could we start off with a definition of that? So Gavin, the question for you is, how would you define what a smart water network is?
It's an excellent question. Many people claim to have smart water networks installed, but from our history, I haven't really seen one that's really complete. So, you know, from our definition, you need to have a central communication network infrastructure. So you don't want 6 different network infrastructures in a city all doing different things. Having a central one, essentially with a common protocol, is really important, and that's what makes it smart, because it lowers the cost of all the connectivity of everyone. Designing networks for low losses is important, making sure that you have minimal buried pipes in the future. You can't change the past, but changing the future, making sure we design for as low losses as possible. So it should start from a design stage. putting in place DMAs, PMZ, pressure management zones, having dynamic real-time pressure and flow management. Of course, the smart water meters and utilizing all of the information that comes out of that, smart water quality and smart pressure sensors. And most importantly, for the thing to actually work, you need a really intelligent back office software that actually utilizes all the data for customer and utility benefits. Heading towards renewable energy and sustainable development goals, you've got to integrate your network with energy and with energy pricing, making sure that you have resilience in place so that ensuring you have low loss networks as well. And just if you had to do it on your own, you would fail. So integration with energy, integration with fire services, integration with recycled water, all of those together for me kind of build it out and make it a smart network.
So it's putting it all together in order to actually have a definitive network. Slavco, David, would you agree? Is there things that you would sort of change or slightly omit in that definition?
What I would add would be that a smart water network is as smart as the users and the managers. That we are still living in an era of artificial intelligence which does not have secondary consciousness, and therefore is up for secondary conscious beings, i.e. humans, to put in what they want out of it. It's not simply a device. If it's simply devices which are used passively on their own, effectively you're adding another layer of dumbness, so to speak, to a dumb network. There's genuine smart networks which are starting to emerge in some utilities, where we're really considering how we integrate the information, and are we gathering data for the sake of data, or do we really have genuine objectives behind getting hold of this data? So the more thought put into it, the smarter the network.
There's a couple of points you mentioned there that I think we will move on to, David, but I suppose just finally then, Slavco, anything that you would add?
Yes, so Gavin described nicely the smart water network, let's say foundations. What I would also like to mention is that what is a smart at the end of the day? So I would put it in a way that we need to make use of the best use of the data we have. Utilities are in different maturity states across EMEA, across globally as I work with utilities. So important is to emphasize that this data or common data environment is very important, that we can make an informed decisions for business outcomes. Now, whether they are smart or not in the future, that will show, obviously, whether we achieve the business outcomes that we set and what kind of data and information we need to do. But the smart water network in essence should cover the complete life cycle. So from a long-term planning, then designing which is now and implementing certain solutions, expansion of a desal plants or a new water network completely, etc., towards operation and maintenance. And this is where I believe, together with SCADA data, real-time IoT data, etc., we can gain much more efficiency in terms of smart usage of the data which is available. And Gavin touched upon, for example, that a smart platform combining everything together and delivering that information basically to make a better decision is a key in this process. So there are different moving parts and components, but putting that together in a connected data environment to make an informed decisions at the end of the day, this is the smart water network.
Perfect. And I think the sort of question that we'll move on to now, which is centered around like the challenges that utilities face, when holistically being sort of incorporated into a smart city, have been sort of touched on there in various points. But the question I will ask then is, what is the sort of main challenge that utilities are facing when rolling out a smart water network? I'll open that up to the floor, whoever wants to jump in.
If you look, if I can start and kick off that based on my experience, let's say working with many utilities globally, every utility is different in a way. They have their own challenges, etc. So if you're talking about investor-owned utilities, they are more regulatory driven and I would say stakeholders driven. If it is a municipal-owned utilities, they need to serve certain purpose, but also deliver safety, in terms of water supply, safety in terms of their, let's say, employees. Then compliance is very important, regulatory compliance. Do we need to report on a non-revenue water, electricity use, service interruptions, etc. And at the end of the day, reducing the operational costs for the total water asset ownership, the TOTEX, I would say. If we are making an investment, we have to take into account the CAPEX and the OPEX in order to address the TOTEX. And final one, we see a lot now, currently, by the way, in the Netherlands, there is a storm coming up, and we see a lot of, some of the electricity substations and also pumping stations maybe underwater. Reliability and resiliency of these water networks is very important. So these are some of the key challenges I see. Non-revenue water will be always there. So this is a problem that we are tackling almost for 30, 40 years. But we see a lot of technology which is coming up and help tackling that problem as well. So safety, compliance, risk reduction of the operational cost, and finally resiliency and reliability of the network, taking into account sustainable development goals, etc. These are the key challenges we see across the globe.
David, I'll move that question to you then. So what do you see as sort of like the main challenges that utilities are facing?
In the immediate sense, it's using smart water to deliver what you might call more for less. In other words, better services, better service perception, and improved demand management. In the longer run, it's engaging with both decarbonizing water utilities and optimizing their ability to face climate change. That you might call that sort of the underlying and emerging area. Ultimately, smart water is about what it delivers. It is, in that sense, somewhat transactional, but the crucial element about smart water is it's not there to be smart, it's there to provide a better utility and a better customer experience.
Okay, so Gavin, just to move this one on then, in order to roll out a smart water or wastewater network, and I suppose in order to sort of overcome a lot of the challenges that have been highlighted there, are there certain technological innovations that need to be created and implemented, or is the tech, and is the sort of, or is the technology there already, and it's just a matter of actually bringing it all together?
I think there's plenty out there. It is poorly used. If you just, let's look at a smart water meter. There's a smart water meter that gives you temperature, it gives you pressure sometimes. It certainly can give you flow rates. And most people, 99% of people, use it for a meter read. They don't even use it for the leakage detection capabilities in order to tell a customer that they have a leak on their house. That's just a simple start of it. There's a lot of pressure management software out there that enables dynamic pressure management of the network. There's certainly a lot of technology out there. There is a lot missing. We're building out smart networks here, and we're looking for, let's say, online sensors as far as water quality goes, as far as pressure over time goes. And it is, or let's say leak sensors as well, which need some technological advancements, certainly need some movement forward. With the utilization of fiber optic, I think there's a lot more that can be done at improving the communications. So there is also a lack of standard APIs for communications, so that would really help the industry grow. Having proprietary communication protocols limits you in what you can actually do and what sensors you can connect. So opening it up to having a 5G communication modules and not having a bespoke network would be very helpful to us. Central software, you can see so many solutions of software out there, but there's very rarely one that will cover you from end to end. Being that from SCADA systems all the way through to smart water meters, etc. So it is few and far between from a software perspective, and maybe it's all there, but you've got to have 6 different softwares in order in order to be able to implement. You know, there's a lack of, let's say, a global master design of the smart water network. You know, if you go out to all the consultants and contractors and say, do you have a design of a smart water network if you ever implement it today? They will all say, well, we have to look at your implementation and how we're going to do it, etc. So there's no, let's say, master reference that you can go to and say, hey, this is, if you had all the money in the world, because financing, by the way, is one of the major issues that people face. But if you had all the money in the world and you wanted to do the best, smartest network, you know, this is what you would do, and then work backwards from there based on what you can afford. So I think there is technology out there. There's more to do, but it is really poorly used, and there's, you know, lack of people understanding what technology is out there. There's lack of capability and experience of technology. But I think it does. I think there is sufficient out there to put a smart enough network into.
So, I suppose to follow on from that, how do we standardize it all? You know, and how do we move it all towards a more, I want to say generic, but that's maybe not the right word. But like I say, like how do we standardize all of the different tech providers so that it is a lot more sort of collaborative?
Well, I guess coming from one of the biggest water companies in the world that had proprietary protocol technology, and we saw Sigfox come out trying to do that. We saw LoRa come out trying to do that as far as communications go. And it's been a struggle for them. Of course, you know, they can claim that it's interoperable, but it is at the end of the day proprietary protocols. And you know, what I'm really pushing for here is 5G, because 5G means you can use any network, any 5G network. So if you have modules that will be able to work on all of your products that were 5G modules, in a plug and play fashion, that would be a huge step towards lowering the cost of all the implementations of sensors on a smart network. So for me, that's step number one. And like I said, having a global design master would be really interesting for us.
Okay. So, Slavco, a question for you, I suppose, on the back of what Gavin was saying about the software side in particular. What role does the digital twin play in a smart water network?
That's a very good question, basically, Kyle, that you're describing, and I see some of the comments also in the chat box that people are putting that, how can we start? In order to start with a smart water network, it's basically a low-hanging fruit. Most of the utilities, they have the available SCADA data already. I mean, water utilities companies were one of the oldest of implementing IoT devices with some data analytics in the past. In the years of 60, 70, we had SCADA systems. So putting this data together, SCADA, together with some models is the first starting block. That can be done pretty easily. And we can claim that we have the first building blocks of smart water network, understanding the visibility and insights, what is happening in the network. Now, there is a lot of discussion regarding what digital twins can provide and what digital twins mean for smart water network. First of all, let me explain the term digital twin. Digital twin is basically a replica, digital model of the physical system, but I would mention the underlying processes, business processes as well. It's not just, you know, one-to-one GS representation of your water network or I don't know, a SCADA simplified view of your water network, but it's really an evergreen digital model that is updated constantly. As a new data come in, as a new changes into the network come in, as a new settings probably based on the dynamics, etc. So digital twin is really an evergreen representation of what is happening in your network in order to support and drive business processes at the end of the day. If I want to reduce the pressure, this digital twin needs to tell me what is the current pressure, what is the anticipated pressure into the coming 6 hours, and we have to set some module which will be more on the market. Some of the question I see that was posed is, do smart water network can use, for example, open source software? Definitely, yes. There are a lot of benefit from open sources in terms of communication protocols, for example, for the SCADA vendors, for the digital water meters, smart water meters, etc. The other side is, I would say, open platform rather than open software, which no one is responsible for. We've seen a lot of open software initiatives die out because someone at the end of the day needs to take care of that software if something happens in terms of emergency. But open platform is probably the way forward for implementing digital twins. And in Bentley, for example, we are working on this iTwin, infrastructure twin platform that we call it. It's an open platform that different vendors can hook up and develop extra applications on top of that.
So how do you integrate a digital twin in a network of sensors from, various years and suppliers? How do you go about that?
Yes, so the first thing is to start is looking at the current data. There is a templatized approach that we take normally. So templatized approach means sort of scanning the network. Okay, what type of sensors we are using, what kind of communication protocols. Is cloud playing an important role? I see more and more utilities globally are making use of the cloud because the cloud technology also comes up with the layers that can integrate this data. There are open protocol connectivity layers as well, especially in the SCADA world, in the digital water meters world, etc. So we make use of these communication protocols for data exchange. And what we did in Bentley is basically we have developed a iTwin platform that takes into account any type of data format. It puts it in a sort of platform independent format, which is basically distributed like a ledger, like let's say the smart contracts which are currently available in the cryptocurrency. So you have a distributed database, and that database knows how to synchronize with different vendors in a real time or a near real time. So there is a lot of technology. I don't want to go into technological discussions, but yes, the first step is really understanding what kind of data we have, what type of systems we have, what is the business purpose of putting this data together. This is the most important question. And then technology exists. So technology exists with a sort of open protocol communication layers that we can create this connected data environment, we call it, as a first step.
Yeah. Do you have a good example of a utility from around the world that has implemented, digital twin and sort of the benefits that have come from that?
Definitely. There are a lot of utilities now moving towards the digital twin space. So I can mention Aquas do Porto. Aquas do Porto integrated 20 different, for example, data sources for their water, sewer, and stormwater network, including bathing water which is collected from the wastewater and also exposing it to the sea, let's say, and the rivers. So they've used a Bentley technology in order to integrate 20 different data sources in order to make, SCADA data and operational models together in order to make an informed decisions, predictive capability, so to say, with alerts, alarmings, etc. So that's one. Another which is very close to me is Evides water company in Rotterdam. Rotterdam now is the biggest city in the world, in the Netherlands, basically, with the port of Rotterdam, very important here. So they also are using information technology, but also using some machine learning, statistical learnings, etc., in order to predict demands, in order to optimize set points, etc. So another company that I can mention is IGEA in Rio de Janeiro in Brazil, which is the biggest utility basically in the world, also implementing digital twins in order to get the benefits from this smart water network. So there are a lot of examples. I can share those examples with the colleagues if they wish. And there is no prescriptive example that gives 1, 2, 3, 4, 5 how to implement smart water network. My advice is start with what we have and don't wait that someone will come and tell you this is the smart water network. It's basically connecting the data together, the low-hanging fruits, and benefiting from that immediately.
So David, what steps do you think we need to put in place for smart water networks to be perhaps more standardized, and maybe like pathways to having a more holistic approach to smart water?
There are two issues here. First of all, that we still are operating in data silos, that too often smart water is introduced one project at a time. The data goes through its platform, through its software, through its set of standards for that output. And you could have any number of outputs and inputs, but they're not being integrated. So first of all, they have to be put together. Now, in a sense, you have to go back to the essence of water here, that unlike electricity, telecoms, and so on and so forth, every water utility has its unique operating circumstances relating to its river basin, its catchment area. And as a result, things like the ITU have noted that smart water protocols are notably non-standardized compared with smart water protocols in other areas. So in a sense, one of the greatest importance we need from the top down is to try and encourage utilities and smart water network developers to produce common standards. And then secondly, it's how we can use those common standards as a platform for integrating information. It's not the end of the world, data silos, it's just simply a missed opportunity. The more standardization and integration we have, the more we can use different bodies of data to help each other and create, to come back to the expression, a more holistic impression about how the utility operates.
So that does actually sort of lead me on to one of my next questions, which would be, in a world where there are different challenges, even within one country, for example, a utility might face a different challenge compared to, one that's in a different location. Whose responsibility at the end of the day is it to implement a smart water network? Does it fall on the hands of the utility, or is it perhaps there needs to be a larger decision sort of maker in who rolls it out? And David, I'll start off with you on that one.
I think ultimately it's the utility, because smart water is simply, when you look at it in a hard sense, it's simply an offering, it's a product. It's something which helps you to do something. The utility's duty, sometimes it is forgotten, is to deliver safe, potable water, safe sanitation, and so on and so forth, universally and affordably. So if smart water is a tool which enables them to do that, and come back to that expression, doing more for less, then it is a good thing. But ultimately, there is no obligation to use smart water, except in the sense that if it's going to help you provide a better service and a more affordable and sustainable service, then you could say that there's a moral obligation for the utility to incorporate into its operations.
So, Gavin, I'll sort of throw that to you as well, in that I think there's a question to be had about responsibility. And I think that there's a lot of benefits when it comes to rolling out a smart water network, and we've sort of gone through those there. But what would be the main reason for a utility to actually roll it out in the first place?
Well, I agree. It is the water utility only. It's only their responsibility. Why they don't do it, we can question. Sorry, remind me of that question again.
So whose responsibility is it to roll out a smart water network?
No, sorry, you didn't ask that question. You asked something else.
Well, I suppose, like, why would a utility do it as well, as opposed to...
Why? Okay, so yeah, if it's financially viable for the utility, they will roll it out. It's the only reason that they will ever do anything. The biggest issue, I've worked with thousands of utilities around the world, the biggest issue they all face is finances. And if they can prove out a business plan, whatever that business plan, I agree with David that these business plans can vary dramatically from every water utility has its own driver. You may think, water utilities are the same, but they're not. Many regulations are different, etc. So they all have their own drivers and they all have their own requirements. And they should have all of their own reasons for rolling out a smart network. They need to prove it out that it's a financially viable business for them. If it's not financially viable, it's like anything in the world, people will not roll it out. The problem you face is they don't have the expertise or the capability or the understanding of the benefits they can get out of a smart water network. And due to that, they are unable to put together a very clear business plan that satisfies this financial return on investment that they have to make. In many cases, they don't even have to do an investment. There are some companies out there that offer smart networks as a service, smart sensors as a service, and they even, there was a company, I don't think it exists anymore, it was called Felon in the US. They went around offering to reduce the cost structure of a water utility by 10 or 20% if they were given the responsibility to roll it all out. They were fairly successful, but in the end, not very successful. So, because they went under, I think. But in the beginning stages, they were very successful at doing it. So it all comes down to financial viability. But the issue that I think many of them face is that the technology providers are unable to demonstrate to them the full benefits of what they're offering. And many times it's because there are so many technology providers that they can't offer the full gamut of what the whole network should look like. Smart water meters is one thing, smart pressure is another thing, smart water quality is another thing. So if you are able to have a company that could offer all these services and very clearly the benefits of that, and demonstrate the financial savings that occur due to that, it would be a no-brainer for most water utilities, even the poorest ones.
So there's a couple of comments and questions that are coming in on the chat. One in particular from Gary Tavor, who I believe is from ATI in the UK. He has made a couple of points about the role that consultants play and the role that or the collaboration that a consultant can offer between a technology provider and a utility. So what role do you see consultants playing in the rollout of smart water?
For us, consultants are, essentially there to bring the industry to us and bring an understanding of what's in the industry. The problem you have is that many consultants are siloed and don't really understand all the technology that's out there. I talk from experience because we've been trying to build out a smart water network here, and we use some of the biggest consultants in the world. And at the end of the day, they go out and get smaller consultants who really understand the market a little better than what they do. But we still don't get everything coming in from them. I do believe that we are lacking smart water network consultants. And even if we ask to design out a network, we've designed out a few networks. And when I look at the network from my experience before, there's so many changes that we make to the networks that come in from some of the biggest design consultants in the world. So I think there is a gap in knowledge of consultants and how they play. And certainly we could do with some really experienced consultants around smart networks.
Okay, so we'll move on to the next question. So Slavco, a question that I'll direct to you, and I suppose it's following on in how we roll out a smart water network. But what role do regulators play? And what role could they play? And I know this is quite a subjective question because there are numbers of regulators in all over the world.
All over the world, yes.
But what role do they play? And what role should they play?
Yeah, it's a very interesting question, Lyle, that you're posing. Look, depends on the geography you are. Obviously, UK is very regulated in terms of the OPFAT is a regulatory body which is implying certain KPIs and certain business outcomes for the water utility on which they are measured, with a little bit of carrot and stick approach. So that's one. Second, there are some self-regulating bodies, like, for example, Scandinavia, the Netherlands, Benelux, etc. The utilities are exchanging best practices in order to self-regulate and benchmark against themselves. You know, moving towards, for example, in Victoria, for example, with what we have seen in Australia, is also a little bit of drive towards digitalization and digital processes. So forcing the supply chain ecosystem, consultants, technology providers like Bentley or AMR providers or SCADA providers to deliver digital twins, no drawings anymore. Simple as that. So there is also an approach that you force a little bit, of course, the digitalization process, which is there, which must be there and embraced. And regulatory bodies can also play an important role of setting the water tariffs. I think with the water tariffs, which are basically the business outcomes of the water utilities at the end of the day, why they exist, it's a social justice, of course, and in minimizing impact of the customers in the environment. But on the other hand, they have to be cost effective and the bottom line. I mean, you cannot exist if you are making losses for a couple of years. So regulatory bodies should be having different mechanisms to talk about regarding minimizing impact on customers, on the environment, be cost effective in terms of the bottom line, and at the end of the day, implementing some digital processes inside the water companies in order to make them more effective and more efficient. Many of the water utilities are going to face shortages in terms of operating staff, in terms of, you know, let me put it this way, hydraulic modeler or a GIS expert or a guy who can open up the hydrant and flush the street, etc., improve water quality. So how to deal about that? Probably digitalization is the answer to that. So we can digitalize those processes, we can capture them. There will be some smartness in the total solution, and this is where the regulatory bodies should play an important role. You know, your KPI should be also measured in terms of digitalization as well, and not just a service interruption or just leakage rates. Let me put it that way.
Yeah. So David, is there a need for perhaps an international body to regulate the regulators and set more of a standard?
It's a very good question. If you look back at for example, the history of the relationship between Ofwat and the English and Welsh water utilities, in a sense, the difficulty with a regulator sometimes is that it's headed by a personality. So the first 10 years of Ofwat was run by a climate change denier, which was a bit of a nuisance when you're a water utility. It's rather like having someone running a car manufacturer who doesn't believe in the use of petrol or diesel. Then we had a regulator who disapproved of the notion of smart meters and metering. In the last 5 years, the regulator has discovered something called innovation. So instead of just having outputs, KPIs for the sake of KPIs, they're actually looking at how can we achieve these. So definitely, I think the crucial element in regulating the regulator is to bring them all together to remind themselves what they exist for, which is to deliver the best quality service for the most people at the most affordable price. In a way, everything else is secondary to that. If we need regulation, if we need innovation and so on, that is smashing. If everything is perfect, just stay perfect. In the case of smart water, it's, in a sense, really providing a framework for benchmarking, for sharing best practice. We're just at the beginning of an exceptionally long journey in benchmarking. For example, removing the headroom for corruption in utilities in certain countries by showing the best examples of what can be purchased at the right price rather than a wrong price, and the outcomes and the headroom for corruption in procurement and contract management. Then there will be the what can you deliver in terms of leakage, water quality, etc., at a price, and what are the circumstances which actuate those service deliveries. So ultimately, I would say when it comes to regulating the regulators, it's more a case of encouraging them to collaborate and to create platforms for data sharing and best practice to encourage utilities to do better.
Gavin, you look like you had a few points then. Yeah.
Yeah, I think you know, we do have the United Nations with this sustainable development goals, which pressure on regulators to achieve certain things.
Yeah.
And then of course you have OECD. I don't know if anyone's familiar, but OECD actually put a lot of data out for regulators to review and follow. So there's a lot of OECD input on regulations, and they do get draft regulations that people should adhere to. I guess I'm in the fortunate or unfortunate position of having to develop out new regulations and new laws for a new region in the world, which we've just virtually completed. And the role that regulators play is enormous. You know, it's the job of a regulator is to protect the I was going to say consumer, but it's actually the customer. So, you know, their job is to protect the customer and to do things and make sure that the utility operates in the best interest of the customer. And very often they don't do that because they don't understand what they do. And a simple one is the non-revenue water. You have to ask yourself why there are not regulations in every country around non-revenue water. Because a 30% loss in a network or a 40% loss in a network feeds straight into your tariff structure. And if it feeds straight into the tariff structure, it means that your customer is paying 30 to 40% more than they really should be paying for their water because of the cost of non-revenue water. So why in every country in the world is there not a maximum limit of 10% non-revenue water that is imposed by regulators? Because that's the biggest benefit that a customer will get. And then I'm going to turn and look at ourselves, all of us sitting here and listening to this, and I'm going to ask you, you are a customer. You as a customer, what have you done to ensure that you don't pay that extra 30% non-revenue water losses? I guess none of you have ever done anything. None of you have written to the regulator and said, why are we paying for this? And we're all in the industry, by the way, and by the way, I count myself into this, by the way. We're all in this industry, and we never complain to the regulator about the fact that we're overpaying because people are not attending to non-revenue water. And the regulators are just happy with the status quo because at the end of the day, very often, and this is what I've tried to avoid in NEOM, but very often the regulator actually reports to the same person as the water utility CEO. So getting that separation is really important as well, but it's really difficult with an inherent country or inherent laws and regulations. But in order for us to push regulations, we as customers of water should also be putting a lot of pressure. And by the way, technology companies should be putting a lot of pressure on regulators, A, to make sure they understand the technology that out there, the benefit it can bring, and B, to make sure that they are doing everything in the best interest of the customer, which quite often I think is not the case.
So I think that's a good point to leave it. What we'll do is we'll move on to some questions that have come in the last 45 minutes or so. We'll start off with another one that Gary's dropped in. He's just asked, can we use smart water to better regulate environmental? Sorry, someone else has just dropped one in. So the point was, can we use smart water to better regulate the impact of poor waste management? David?
Very much so. I've been coming across a number of companies who are developing remotely enabled water quality metering. So moving away from occasional passive testing of inland water quality to real-time continual monitoring of various parameters. It means that you can identify a pollution incident when it happens rather than when the dead fish start emerging. And we have the potential to be able to go upstream and work out where and when it happened. So, for example, in England and Wales at the moment, a owner of an industrial agricultural site knows that they can discharge waste into rivers with impunity because there is effectively no monitoring. Then the Environment Agency has admitted they can't afford to monitor inland water quality anymore. With remotely enabled monitoring systems put in, which are far cheaper than people assume. You're talking hundreds of pounds, about a couple of £1,000 a unit, rather than tens of thousands, and minimal maintenance and management costs. You can turn this entire picture around, use DNA, for example, to trace back the pollution to which species, and so on and so forth, and create a climate where it actually is bad business to poorly treat waste.
Yeah, I think there's a lot to be said about the way that, well, certainly the environmental impact that the wastewater networks are having. So do you think there's an argument for more fines and penalties for improper waste management?
Very much so. Again, looking at the case of the UK, until recently, water companies were allowed to act with impunity. I find it astonishing that various companies, I'm not going to name them, that have a active policy of letting waste be discharged when there's no need for them to discharge that waste. Why aren't their directors in prison? They ought to be in prison. I think seeing them and various managers of private equity companies, okay, open prisons, but something like that would focus people's minds. And there are smart techniques to both encourage them from outside, and secondly, so that to expose them to their own poor corporate practice. It's not a very nice thing, but it is. That's right. And we've just seen here, hit the share price. I want to see private equity companies suffer. I want their investors to suffer, because investing in a company like Thames or Southern Water isn't just simply a case of ripping money out of them. Actually, you have to do something back. There has to be more to private equity than being a vulture. And I think water is a classic example of a sector where, in fact, private equity is just congenitally in unsuitable investment mechanism. And it's up to the regulator and up to the legislators to decide, what do we want from our utilities? Are they just something for people to rip money out of, or are they actually there to deliver a service?
I think that ties into what is certainly in the sort of ESG standpoint, it's a growing area, isn't it? I think we would hopefully start to see ESG initiatives being pushed more and more. Now, there's another question that's come in, and Gavin, I'll direct this to you. It kind of touches on one of the points that you made earlier about the supply chain that's involved throughout a tendering process. So it's a question that's come in from Berry. And he says, is the holistic approach of, or at least trying to cover the full breadth of a smart water network, actually compatible with a typical tendering process that tends to split up those systems into multiple parts? So is there a change needed in a sort of a tendering process, do you think, in order to roll out more comprehensive smart water networks?
I think when you get to a tender process stage, it's either the consultant has put it together based on your requirements, or there's a financial requirement directly from the water utility if they haven't used a consultant. And very often the result of tender is a result of their knowledge. And it's a result of the market that they understand. Very often and in my previous life, we've tried to change tenders because we believe that what they've actually tendered for is not what they actually need. So these are issues that I've faced many, many times, is that, and by the way, we send out tenders on this aspect virtually every week. So making sure you get the tender right and making sure that you understand the marketplace clearly. If it's pressure management you want, and you go out to tender for smart water meters, you're not going to get what you want. I guess the question is there a case to put all of this together in one tender and ask for everything across the whole gamut of a smart water network? And I don't think that's required. We used to go out and go to small water utilities in Africa that had 60% losses. And we only used to put in 10% of smart water meters into their network and resolve 50% of their losses, just because that's all they really needed. So to go out and just put smart water meters everywhere for a small water utility in Botswana or in Mali is not really viable, because firstly they don't have the cash to do that, and secondly it's not really necessary to do that, because 90% of the issues are only coming from 10% of their customers. So I'm not sure whether I answered the question, because I don't really understand 100% what holistic tender would be like, but I think it's a horses for courses when it comes to RFPs. But issue number one is that so many times in my previous life, we saw that the tender that came up didn't really reflect exactly what the water utility wanted.
Yeah.
So making sure that you work with the water utility so that they really understand, that you really understand what they want, so that you can offer what they want, rather than just what comes out in an RFP.
I mean, this actually ties in really well with sort of our last question before we wrap things up for today. But how do we then balance the solutions that are offered with the problems of the utility? And Slavco, I'll direct this to you. So, how do we balance one size fits all solutions versus the needs of, particular problems from various regions?
Yes, most likely the answer to this question is various regions have different challenges, obviously, various cultures playing a role, various procurement processes also in terms of the buying process. So my advice would be there to look at the best or good practices, I call them. They're not best practices, obviously, but good practices around the world. Talk to peers in the industry, like on these forums, or more, let's say, closed forums, to understand basically and build capacity to execute a right procurement process. I've seen some companies outsourcing the procurement processes to business partners, basically those people who know to write specifications, who listen to the water utilities, what are their business problems, what they want to achieve with this tender, and finally driving the process such that it is not biased. Sometimes the water utilities are, of course, busy with their daily job, obviously delivering services to customers, and they are biased in terms of the vision, the big thinking process, and how to scan the technology landscape as well in order to implement the best technology for their needs. So there is no most likely one size fit all, but learn from good practices. Sometimes outsource the procurement process, I would say, to independent party that is can drive this and knows the market and can translate the business requirements towards technological solution. That is probably the way to go.
Perfect. Well, I think that's a very good place to leave it for today. So a big thank you to our panel. Thank you very much to David. Thank you very much to Gavin. And obviously, thank you very much to Slavco. Apologies if we've not been able to address your question from the chat. If you do, drop myself a message over LinkedIn or go to our website, or obviously drop a message through to any of our panel. I'm sure we'll be happy to answer any of the questions that we maybe missed. A couple of points from my side that a video recording of this discussion will be released soon. So look out for that in your emails. We'll also be creating a downloadable PDF featuring sort of the main takeaways from today. So as well as that, we'll be sending out any insight from the future of smart cities. So we're hosting obviously a whole range of webinars throughout the course of this week. So again, keep an eye out for that. Obviously, if you've enjoyed today's webinar, then don't forget to sign up. We're running lots more this week, covering all aspects of manufacturing, smart buildings, construction, cybersecurity. There's actually a link in the chat if you wish to sign up. And finally, from my side, if you do have any upcoming hiring projects or would like to find out a little bit more about CM Industrial and about how we're striving to change the way that the world sees recruitment, then please do get in touch. You can send me a message on LinkedIn or obviously have a look on searchingindustrial.com. But that's it from our side. So thank you very much for attending and have a great day.